What I have here is your first intro to some differential equations. This is a popular topic. We'll do with two variables later on. Right now we're just doing with one variable. And so what we have over here, you see there's a picture that's with it. These are slope fields. And all these are the maps of the individual slopes at individual points. And so you can kind of see it follows this pattern. If you would trace these slope fields, it's basically a bunch of parabolas, and these represent all the solutions for different c values. So if you started with the same function and you integrate, you end up with multiple solutions until they give you a point. They give you a particular solution. So you start out with the slope. So it's a differential equation because there's derivatives and variables. One half x minus 1. Technically, when you do this, you multiply both sides by dx. It's just good practice for what we're going to do when we go with two variables. And so you have something you take the integral of both sides. And so when I take the integral of the left side and integral of the right side, integral of dy is just y. The integral of this side is our differential that we've been solving. So I raise that by 1. I'm dividing it by 2 because that's what I raised my power to. So 1/2 divided by 2 is 1/4. And you can always check the derivative to see if you get the same thing. Minus x plus c. So for different c values, you could have different solutions. So if your c value was down there, your solution would be this. But they give us a particular c value. They say through the point 4,2. So that's 2 for y and 4 for x. And we're going to find that particular c. So 16, that's 4 minus 4 plus c equals 2. So c equals 2. So the general form of this equation, the solution to this slope field they give us is 1/4 x squared minus x plus 2. And that's the equation of the parabola that goes through that given point. You can kind of see it would hit right there. I didn't do a very good job of tracing it. It probably would hit right at 2. Okay, and later on, as the year goes on, we will do this when there's an x and a y, but right now there's just an x. So that's your final solution.